Hello. In this video we're going to go through question 3 from lesson 3. So the question is, given the points 0, 0, 0, 4 and 4, 0 are 3 points in a circle, find the radius of the circle and its area. So this problem can actually be quite challenging if a couple observations aren't made. So what I've done here is I've drawn a Cartesian plane, I've plotted these points, and I've named them. And that helps us talk about this question. So it's always important, if the question doesn't give you labels for each point, make them up. That way when you're communicating, it's that much easier. So what jumps out at me right away with this question is that if I actually connect these 3 points, what I end up getting is a right angle triangle. And right angle triangles are always things to look for in mathematics because typically there's lots of fun properties and rules and laws that you can apply with them. And in this case, there's a particularly nice theorem called circle theorem, which has a law associated with it, which is wonderful to know. We don't actually cover it explicitly in our course, but nonetheless, it's a great law to know, especially for those of you writing contests. So I have a little circle here, and the law that I'm talking about is as follows. If I draw the diameter in any circle, so there's my diameter in this circle, okay, there's my center. So if I pick a point anywhere on this circle, so let's pick one here, and I create a triangle using the diameter and the line segments created by connecting each end of the diameter to that point, the angle here will always be 90 degrees. So whether I put the angle here, the point here, or I put the point here, the angle here will always be 90 degrees. And that's a law in the circle theorem which is really useful, and particularly is useful in this question. So since I'm making a circle out of this right angle triangle, what I know is I know that BC, the line segment BC must be, don't mind that, must be the diameter. So since this is a diameter, what I can do then is I can find the length of BC. So the length of BC is the square root of 0 minus 4 squared plus 4 minus 0 squared, which is equal to the square root of 16 plus 16, which is equal to the square root of 32, which is equal to, and again we can apply some rules of radicals. I'm going to think of what is the perfect square that is a factor of 32, and of course nicely that is going to be 8. So this can be written as that's going to be 16, so this can be written as 2 times 16. And we know the square root of 16 is 4, so that means if we take the square root of 16, we get 4, and the root 2 is still there. So we can write this as 4 root 2. So therefore, if the length of BC is 4 root 2, the radius must be 4 root 2 divided by 2, which is equal to 2 root 2. Okay. That works out well. So now we get 2 root 2. So therefore, we know the area of a circle is equal to pi r squared. So therefore, the area of this circle is going to be pi times 2 root 2 squared, which is pi times, and we have to square both the 2 and the root 2, so that's going to be 4 times 2, which gives me 8 pi. Now again, the temptation here for a lot of students is to multiply 8 times pi, but in this context there's no need. So what I'm going to do is I'm going to leave this as 8 pi, and unless there's some reason to change it, I won't. So therefore, the radius of this circle is 2 root 2, and the area is 8 pi. So again, this question, once you make that connection that BC must be the diameter of the circle, it becomes pretty easy. And there's a number of ways you can make that observation. I did it because I knew this great law in the circle theorem. However, there are other ways to do this. Now, that being said, this question can be made much harder if we have a triangle that's not a right-angled triangle. And I'll add another little video that goes through another example where the numbers or the situation isn't as friendly, so to speak. I hope this video helped.